Hello from the Forcetronics YouTube channel and welcome to Maximizing Arduino's ADC Resolution and Accuracy, Part 2. And in Part 2, what are we going to look at? We're going to look at how to increase our ADC measurement accuracy by using the built-in noise reduction mode. So what is the noise reduction mode, or NRM? Well, it's built into a lot of the Arduino chips, specifically the 328 and the 168. The 328 is in, the Uno, it's in the Pro Mini, so on and so forth. And actually, the noise reduction mode is one of the sleep modes. So most of the sleep modes, we use them to reduce the power consumption of the chip, so to save battery power for battery power design. This actual sleep mode is actually to reduce the noise level in the measurement hardware when the ADC is making a measurement. So how does that work? Well, in sleep modes, you're basically shutting down parts of the chip that doesn't need to be used to conserve power. Well, this is similar. We're going to shut down some of the clocks in the internal chip, including the CPU clock, to basically reduce the noise level inside the chip. And what this does is it keeps out this parasitic noise. So you have all these clocks running on the chip and in these small confined areas, and there's just no way to prevent this clock noise from sort of getting into the ADC measurement hardware. So by shutting some of these clocks down that we don't need and then making the measurement, we're going to get a cleaner, lower noise measurement. If you're not familiar with sleep modes, I did a series on reducing Arduino's power consumption, and in parts 1 and 3 I show examples and talk about how to use sleep modes. One thing that gets a little more difficult here is in part 1, when we did our ADC measurements, we could use the built-in Arduino functions for our ADC measurements. Here, we're going to actually have to get into the registers to leverage or to access the noise reduction mode capabilities. So we can't just use the simple analog read function. So there's 2 registers we're going to be concerned with, and I'm going to go over them quickly, but I'll show them in the example we're going to look at later. So the first one is the ADC SRA register. So this is an 8-bit register. This register is for controlling the ADC. And if you remember, bit 7 we actually looked at before in the reducing power consumption, because bit 7 turns the ADC on or off. In our example, we're going to set the ADC or make sure the ADC is on by setting that bit to 1. We're also concerned with bit 6. Why? Because bit 6 is basically what triggers or signals the ADC to make a measurement. So by setting 6 to 1, the ADC makes a measurement, and then once the measurement's finished, 6 goes back to 0. And then the other bit in this register we're going to be concerned about here is bit 3. And bit 3 we're going to set it because if you set bit 3 to 1, that means an interrupt will be triggered when the ADC has finished its conversion. And we need this interrupt. Why? Because we're going to enter a sleep mode. The sleep mode is going to tell the Arduino to make an ADC measurement because it's a special noise reduction sleep mode, and then this interrupt is what's going to tell the chip to wake up from sleep mode because our measurement is finished. And if you're new to interrupts, I have a video on how to interrupt your Arduino, which I'd recommend checking out if you're not familiar with interrupts. The other register we're concerned about here is the ADC mux, and this is used for selecting the reference and also for selecting the ADC measurement pin or channel. So bits 7 and 6 are used to set the reference. Bit 5 just selects how the measurement result is oriented. Since it's 10-bit, it crosses 2 registers. So not too much concern there. We're just going to leave it at 0 so it's right adjusted. And bits 3 through 0, so 4 of the bits are what chooses the channel. So we're going to use channel 0, so we'll just have those 4 bits at 0 in the example. And speaking of the example, let me show the results of the example, and then we'll dig into the code. So for this example, what I'm going to do is I'm going to do ADC readings in the noise reduction mode, and then I'm going to do it in the normal ADC mode. And we're just going to measure a 3.3 volt level. So I have a power supply that's putting out a nice clean signal because we want a good reference signal here to show these results. And then I'm just feeding the 3.3 volts from the Arduino Uno into the ADC, which is going to be a 0 pin. So here's the results, and I made 10 measurements for each, and I then did it 3 times just so you can kind of see that the results are not random, that they're fairly consistent. So at the top I'm using the noise reduction, and at the bottom I'm doing no noise reduction or normal measurements. You can see the noise reduction is actually closer to 3.3 volts. And that's simply because we don't have that noise on top of our constant voltage level being measured by the ADC. So let's look at the code now that we saw the examples and the benefit of using the noise reduction mode. Okay, so here is the code. Here at the top, I use the sleep library so we can use functions for calling the sleep capabilities rather than registers. I then create two arrays to hold 10 readings each. One is for my normal readings and one is for my low noise readings. Here I configure some integer value for my ADC SRA register, and I basically use the three different references. Now I just leave the channel the same in each, so these last four set the channel, I just let it at A0, but here is the two first bits is where I set the reference. So I set my AD mux, which is the numbers we just looked at, or the integers we just looked at, to AVCC, so it's going to use the power supply voltage level as the reference voltage. And then I'm just going to control the individual bits for the next register, the control register, the ADC SRA. And first I set this bit, which turns the ADC on if it's not already on. I then tell it to interrupt when a conversion is finished. I then set the prescaler, which actually I don't think I mentioned in the slides, but the idea is the ADC has to have a clock, and the clock has to be, the datasheet recommends between 50 kilohertz and 200 kilohertz to get the best accuracy. So you have to divide the system clock down to a clock value within that range. So I used a prescaler of 128, and that's what these bits are setting. And that gave me a clock, because my Arduino Uno has a 16 megahertz clock, that gave me a clock signal of 125 kilohertz. So that's all I'm doing there is setting up my clock. Now, if you're using a different Arduino that has a much different clock frequency, you may have to change this up. I then enable the sleep capability. I then set my sleep mode. So my argument is sleep mode ADC. This is basically setting my noise reduction mode that we've been talking about here. So I'm setting my sleep mode. I'm not yet going to sleep though. And then I'm going to use this for loop 10 times to make my noise reduction ADC measurements. So I enable the interrupts. I use this function. This basically puts my CPU to sleep. Now, since I use this argument up here, when my CPU goes to sleep, it automatically initiates an ADC measurement. So once I go to sleep, I shut down these clocks that I'm not using to reduce the noise. The ADC measurement starts. Remember that it's going to generate an interrupt. It generates an interrupt once it's done, and this is where the code starts again. And the ADC here is a register. I'm going to grab that and store it in my array, and I'll do that 10 times. Then I do the same thing for normal ADC measurements. And the difference here is I don't have the sleep mode to start my measurement. So what I'm doing here is I'm using this bit, which we talked about in the slides, the ADC SC, and this bit basically starts an ADC measurement. I then wait for that bit to go back to 0, because that's when the measurement is complete. So I'm just going to stall until that happens, and then I store it in my other array. And of course, I execute it 10 times. Next, I'm going to start my serial monitor and then print out my readings. And the reason I waited to do that is because I didn't want a bunch of, or I should say the serial capability or the serial functions for Arduino use interrupts. And I didn't want to mix in interrupts with my sleep mode, because that can sometimes cause problems. I didn't want multiple interrupts to be happening around the sleep call. So that's why I chose to do the serial later in the code. So I start my serial. I then stall until I open my serial monitor and actually send some character. And then that'll get us past that while loop. And once we get past the while loop, I'm going to print out a heading. Then I'm going to print out both of my 10 arrays, or arrays of 10 values, and that's what we saw on the slide, the results. So this is all in the setup code, by the way. I don't do anything in the loop. I have this function set up to convert my, remember the ADC is returning an integer value between 0 and 124, I should say 0 and 123. I want to convert that to a voltage value. And I call the function up here in my serial calls. And then here's my formula to convert it to a voltage value. And then this last function down here is the interrupt service routine. So if you're familiar with interrupts, you have to have an interrupt service routine. So even though I'm not doing anything in it, I have to have it in the code for everything to work right. Okay, so that's the code. Okay, that's it for part 2. In part 2, we just looked at how to further maximize ADC accuracy using the noise reduction mode. And we saw in the example that we clearly get an accuracy benefit when we reduce the noise. For the code that we went over, you can grab it at my blog. Stay tuned for part 3. If you liked what you saw, subscribe to my YouTube channel. And if you have any questions, feel free to email me. Thank you for watching.